Okay, so when we're in modulus argument form, so when we're in rectangular form, we write it with the real part plus the imaginary part. When we're in modulus argument form, which is, I said polar, it's also called trig, we write it in this form. So this is our modulus argument form. You have your radius, which remember is a squared plus b squared, or x squared plus y squared, the square root. And then you're going to write cosine theta plus I sine theta. So cosine theta corresponds to your real part. The sine theta part corresponds to your imaginary part. And you can abbreviate that by calling it r cis theta. So cosine is the C, I, S for sine. Okay. This is the problem we just did. So we know that that was equal to 2 cis 11 pi over 6. A lot of times, instead of writing it that way, the alternative is to write it as 2 cis negative pi over 6. So you'll see both, right? It's the same exact angle, it's just labeled two different ways. This one here, we need to, before I show you how we multiply them, I want to convert that one first. So remember, to get r, you're going to go x squared plus y squared, square root it. So that'd be 1 squared plus 1 squared. So that's going to equal root 2. And then to find your theta, this time we'll go ahead and we'll use tangent. So tangent theta is going to equal 1 over 1, which is your y over your x. Now, I usually just do a real quick check in my head. 1, if I was in the rectangular plane, I'd go over 1, up 1. I'm in the first quadrant, so I know there's going to be more than one time where tangent equals 1. I'm going to pick the answer that is in the first quadrant, and hopefully you remember that that is when theta is equal to pi over 4. So this one here would be root 2 cis pi fourths. And then the second one is 2 cis, and I'll go ahead and write 11 pi over 6 for this one. Okay. All right, now if I want to multiply them, if I'm going to multiply two complex numbers, what I'm going to do is I am going to multiply the radii, and I'm going to add the angles. So it's going to be cosine theta 1 plus theta 2 plus I sine theta 1 plus theta 2. And I'm going to do that in a proof, an algebraic proof on a separate video, just because it's kind of long. So in this case, we're going to go root 2 times 2. And then we're going to go cosine pi fourths plus 11 pi over 6 plus I sine pi fourths plus 11 pi over 6. Okay, so we're going to get a common denominator here, which would be 12. So this will be 3 pi over 12. This will be 22 pi over 12. So what is that, 25 pi over 12? And I'm going to go ahead and go to cis here because I'm going to get the same answer on the other one. Let's just make sure. That's 12. That's 22. That was not correct. Hold on, I got to do it over here. 3 pi over 12 plus 22. Oh, it was 25. Okay, now that angle is bigger than 2 pi. And we want to make sure we simplify. So pretty much all you're going to do is you're going to subtract 2 pi from it. So in this case, that'd be 24 pi over 12, which is then going to make it 2 root 2 cis pi over 12, right? Because basically what you did is you had gone all the way around the circle and then ended up at this same point. Now I want to show you if we had written, instead of 11 pi over 6, if we had written the alternative, which was negative pi over 6, so I'm going to just use the cis notation for right now. Here, when I get a common denominator, it's still 12. I'm going to get 3 pi over 12 minus 2 pi over 12. And notice here, I don't have to worry about simplifying my answer. It's already going to be simplified. So there is an advantage to using, if you're in the fourth quadrant, go ahead and using that negative angle instead of the positive angle. But ultimately, you're going to get the same answer, so it really is a matter of preference. Okay, so that's multiplication. I'm going to show you a division real quick. So with division, when it's division is, your rule's going to be, if you want to divide two complex numbers, you're going to divide the radii and you're going to subtract the angles. Okay. All right, so in that previous example, we had Z1 was our root 2 cis pi fourths. And then Z2 was 2 cis, I'm going to do the negative one this time, negative pi over 6. So if I'm going to divide those, I'm going to go 2 divided by root 2. This time I'm going to subtract the angles. So I'm going to go cosine pi fourths minus negative pi 6. And then plus I sine the same thing. Okay. So this will be 3 pi over 12 plus 2 pi over 12. We're going to end up with 2 over root 2 cis 5 pi over 12. And then you would simplify that. You'd get 2 root 2 over 2, which is just root 2. Now, here's something that's kind of cool. At least I think it's kind of cool. Is this value is not on the unit circle, right? So if I wanted to know what the cosine of 5 pi over 12 is, I could go back to my rectangular format and I could find the equivalent answer and then set them equal to each other. So here's what I mean. So we ended up with cis 5 pi over 12, right? So let's write that down over here so that we remember. And over here, I'm going to go back to what they were. This one was 1 plus I. And this one was root 3 minus I, right? So when we divided them in the trig, polar, modulus argument form, we got cis 5 pi over 12. If I divide them in the rectangular form, which, so remember, that means we're going to multiply the numerator and denominator by the conjugate. I'm going to get in the numerator root 3 plus I root 3. Then I'm going to get I squared, which is minus 1. Remember the shortcut when you multiply by the conjugate. So remember you have Z and then the conjugate is Z star. We would get A squared plus B squared. So we're going to get 3 plus 1, which is 4. So I'm going to end up with negative 1 plus root 3 over 4 plus I, and then 1 plus root 3 over 4. I just factored out an I from these two. So these are equivalent. They're both the answer I got when I divided the same expression in two different formats. So that means the real has to equal the real and the imaginary has to equal the imaginary, which means that the cosine of 5 pi over 12 as an exact value, which your calculator will not give you because it gives you the decimal, is root 3 minus 1 over 4. And the sine of 5 pi over 12 is 1 plus root 3 over 4. And that is pretty cool.